All of you, good morning.
Good morning,
Good
sir.
morning, sir.
Good morning, good morning. All of you can able to see my screen?
Yes, sir.
Yes, sir.
Hmm. We will continue the same problem. We will continue. Hmm. What is the system here? It is a system of methanol and ethanol. Both methanol and ethanol is substantially ideal. Means both will be highly soluble, okay, and form a homogeneous mixture. Forms homogeneous mixture. Okay. The expression which is given at the bottom, that relates vapor pressure and temperature. Vapor pressure temperature relation for methyl alcohol and ethyl alcohol both are given. Okay. If you want to know the vapor pressure at one particular temperature, you have to substitute in the right side. You have to substitute. Right side you have to substitute the temperature, and after substituting the temperature you can find out what is the corresponding vapor pressure at that temperature for methyl alcohol. For methyl alcohol you have to use this expression, for ethyl alcohol you have to use this expression. Okay, then first what we have to do, we have to find out what is the boiling temperature of methyl alcohol and ethyl alcohol. Separately we have to find what is the boiling temperature of methyl and ethyl alcohol. Separately we have to find out. Okay, how to find out that one? The entire experiment or the entire system is at a pressure of 1 atmosphere. 1 atmosphere will be equal to 760 mm of mercury. Therefore, in both the first and the second expression, we have to substitute in the place of PeMeOH, Okay, here you have to substitute 760, 760 to find the temperature, boiling temperature. Similarly, in the ethyl alcohol also, here in this place, you have to substitute this 760 mm of mercury to get the boiling temperature of ethyl alcohol. Both you have to find out. Okay. Then, after finding the boiling temperature, okay, you have to select in between. You have to select different temperatures. You have to select. Okay, the boiling point of we calculated the boiling point of ethanol is 78, and the boiling point of methyl alcohol is 65. As a okay, that we calculated initially. By substituting 760 in the first equation, we got the boiling point of methanol, and by substituting 760 in the second equation, we got the boiling point of ethyl alcohol. That's all. Okay. Now what we are going to do, we have to select from 65 to 78. We have to select different temperatures. We have to select. Okay, and for that temperature, we have to find out what is the equilibrium vapor pressure of methanol and as well as ethanol. We have to find out methanol and ethanol. We have to find out. Okay, that is the next step here. Okay, see here I will log everything. Uh, here. See here, ethanol and ethanol, isn't it? Okay. Now I have to select the different temperatures. I have to select. Okay, the boiling point of wait, hold on, 2 seconds. Wait. All of you wait for a few seconds. I will connect the tag. We found out the boiling point of a methyl alcohol. The boiling point of a methyl alcohol is boiling point of methyl alcohol. Okay, methyl alcohol is 65 degrees. Okay, and the boiling point of ethyl alcohol. Boiling point of ethyl alcohol is mm, 78 degrees. 78 degrees. Okay. Mhm. Therefore, what we have to do now, we have to select the different temperatures we have to select. Okay. Therefore, what is the mean between the 65 and the 78? We have to select a different temperature. Therefore, the first temperature, of course, is a 65. The second temperature I have arbitrarily selected, that is a 68. Okay. Then 70. Then 72, 74, and 76. The last one is a 78. 78. Okay. For each and every temperature, I have to find out what is the equilibrium vapor pressure of ethyl alcohol, that is A, EA0 and PB0 I have to find out. EA0 and PB0 I have to find out. Okay. Then to find that one, what we have to do, we just substitute the value of 68. This 68, okay, you have to substitute here, here. Here you have to substitute, okay, and find the value of the vapor pressure. This vapor pressure you have to find out, okay. Similarly, the same 68 you have to substitute here and find the vapor pressure of ethyl alcohol, okay. Therefore, that is the PA0 is the vapor pressure of methyl alcohol at a temperature of 68, and the PB0 is the vapor pressure of ethyl alcohol at a temperature of 60 degrees. First, we have to find out these two. Okay, all of you do this calculation. Let me know what is the answer. You substitute 68 in the first equation and try to find out the vapor pressure of methyl alcohol. Similarly, substitute 68 in the second expression and try to find out the vapor pressure of methyl alcohol at a temperature of 68 degrees. Okay, that's all. Okay, first all of you, you do this problem, you do this exercise and let me know what is the value that you are getting. Okay. Take the first expression. For the first expression, okay, what we have to do, log of methyl alcohol, log of the pressure of methyl alcohol, vapor pressure of methyl alcohol in terms of mmHg, okay, that is equal to 7.48484863 minus, okay, 1473.11 whole divided by, okay, 230 divided by 230 plus what is the temperature I have selected, 68. Okay. Then whatever the value you are getting, for that you have to take the anti-log, the base 10 you have to take. Okay. That will give you the methyl alcohol, the vapor pressure of the methyl alcohol at the selected temperature, 68 degrees. Similarly, you have to find out for the methyl alcohol also you have to find. All of you do this calculation. Let me know what is the answer for this one. All of you make it fast. 68 equal to, what is this? 794. What is Jayavani? 68 equal to 794.32. What is it? At 68, 794 you are getting. Jayavani, you have written something in the, okay, that is 794.32. What is the vapor pressure? Okay, okay, that's the first case. Methyl alcohol vapor pressure, okay, for Hg, okay, in terms of Hg, okay. Okay, therefore 794.32, 794.32. Okay, the value she calculated as 794.32 mmHg. Okay. Similarly, you have to find for the case of a ethyl alcohol, you have to find it. How to find out the ethyl alcohol? What is the expression here? Log of, okay. Then pressure of ethyl alcohol, EOH, okay, in mmHg, mmHg is equal to 8 point, okay, 0.449494 minus 15543 whole divided by triple 2.65 plus 68 you have to add here. Okay. Now find the value of the right side. You find the value and take the anti-log. You will get the answer. Okay. Now for you to let me know what is the answer, or the left side what is the answer, or right side. Okay. Second expression. What is the answer you are getting? You tell. All of you make it fast. Darshia, name is 20, I think. The number is 20, I think. Darshia, what is the value? Darshia, what value you are getting? Nishant, tell me, Nishant. Why all people are silent? You tell me. What is the answer?
சார் நான் இப்போ சார் உள்ளே வரேன்.
இப்பதான் உள்ளே வரையா?
சார் நெட்வொர்க் ப்ராப்ளம் சார், வெளியே போயிட்டேன்.
சரி, okay. Sir, okay, tell me what is the answer here. All of you tell me what is the answer. Sweta, Riya, Dikshita, Jintu, Sara, everybody is sleeping, I think. No, nobody's. Okay, how much you are getting? 497.73. 497.73. Okay, that is okay. For the anti-log, after taking the anti-log, I think, is it Jimmy Thomas? This value is after taking the anti-log, isn't it? And after taking the anti-log of the whatever the value you are getting in the right side, for that you have to take the anti-log. After taking the anti-log, you are getting the value 497.73. Okay, 497.73 you are getting. Okay, therefore. The value you are getting as the 497. Equal to 497 point something or 23 something. Okay, so much of mm of Hg. Okay, this is what this is the partial pressure, not partial pressure, equilibrium vapor pressure, PA0. PA0 of methyl alcohol, and this is the PB0 of the ethyl alcohol. That's all. Okay, at the temperature of 68 degrees. Okay, then with these two values, we are going to find out what is the value of X and Y. What is the value of X and Y? What is X here? X is the mole fraction in the liquid. X is the mole fraction of methyl alcohol. Why I am specific to the methyl alcohol? Because methyl alcohol is more volatile. How do I know that methyl alcohol is more volatile? Just by looking at the vapor pressure. If you see the vapor pressure, the vapor pressure of this methyl alcohol is very high compared with the vapor pressure of this ethyl alcohol, isn't it? Okay, therefore it's very high. Therefore, they say A is the more volatile. Here, the more volatile is a methyl alcohol only. Okay, shall we do this one? Okay, we want to find out what is the value of X. Okay, for the selected temperature, first you have to find out what is the PA0 and PB0. Okay, we have to first one. The first step is we have to find out what is the pure boiling point of pure methanol and boiling point of pure ethanol. You have to find out first by using the total pressure of the system. The total pressure of the system is given as 1 atmosphere, which is equal to 760 mm of mercury. You substitute in both the equation and try to find what is the temperature. Left side temperature term is there in the denominator, that you have to find out. Okay. Therefore, initially we did that one and we found that the not vapor pressure, the boiling temperature of ethanol is a 78 and the boiling temperature of the methanol is a 65. Okay. Therefore, next what we have to do, we have to select arbitrarily, we have to select randomly, we have to select. Okay. Some temperature between the range 65 to 78. Therefore, I have selected the temperature 65, 68, 70, 72, 74, 76. Okay, all this temperature I selected. For each and every temperature selected, you have to find what is the vapor pressure of methanol and ethanol. That is the next step. Okay. Then we selected the temperature 68 here. Okay, we selected the temperature 68 and for that we calculated the vapor pressure of methanol and ethanol as 794.32 and 497.23. Okay, for this temperature we want to find out what is the value of X and Y. That is XA and YA we want to find out with the help of Raoult's law. That's all. Okay, now I write here. Okay, according to the Raoult's law. What is the Raoult's law here? Raoult's law. According to the Raoult's law, okay, that is this is PA0. Otherwise, we can say the partial pressure in the vapor state. Okay, that is equal to PA0 into X of A. We can write like this: PA0 into X of A. PA0 into X of A. Okay. Then the total pressure I can write like this. The total pressure PT, okay, that is equal to partial pressure of the compound A plus partial pressure of the compound B. Wait, I will remove this one, okay, because it will be starting from here. It will be more convenient. You can understand better. Okay, see here, the system is like this. We have a mixture of methanol and ethanol here. Methanol and ethanol both are present here. Okay, here in the form of a liquid, over which both the vapor and both the vapors of methanol and ethanol will be there. But here it is in the vapor form. Here it is in the liquid form. That's all. These two are in equilibrium. Okay, at a temperature of 68 degrees. Okay. Now, if it is so, I want to find out what is the composition here in the liquid and what is the composition in the vapor. I want to find out. Okay. First, we will start from the vapor. Okay. Then, for the case of a vapor, okay, for the case of a vapor, the total pressure of the vapor, total pressure I can write partial pressure of the ethyl alcohol plus partial pressure of the methyl alcohol I can write. Isn't it? Okay. So for this partial pressure of the methyl alcohol, I can write PA0 into XA, okay, plus PB0 into XB I can write, PB0 into XB I can. This XA and XB are the mole fraction of the XA is the mole fraction of the methyl alcohol. XB is the mole fraction of the ethyl alcohol. That's all. In our case, in the one we have only two components, binary system. This one is the binary system. We have only A and B. Therefore, for the binary system, I can write for binary system, binary system. I can write, okay, this is XA plus XB, that is equal to 1. that is equal to 1, or xb is equal to 1 minus xa. I can write 1 minus x. Okay, this I am going to, this one xb is equal to 1 minus xa. This I am going to substitute here. I am going to substitute. Okay, then after substitution I will get pt, that is equal to pa0 xa plus pb0 pb0 into 1 minus xa. That's all. I can write like this. Okay, I know the value of a PA0 and PB0. At a temperature of a 68 degrees, the PA0 here I have calculated 794.32, and PB0 I calculated 497.23. You substitute here, and what is this PT? PT is the total pressure of the system. What is the total pressure of the system, which is equal to 760 mm of mercury? That is given, which is equal to 1 atmosphere. That atmosphere I converted into mm of mercury. Okay, therefore what I can write, 760 equal to, okay, the PA value is 794.32. okay, then XA plus, what is the value of a PB0? 497.23 into 1 minus XA into 1 minus XA. That's all. From this, find the value of XA. Okay, therefore all of you tell me what is the answer for this case. All of you let me know what is the answer. 760. Okay, 760. After finding, what we have to do, after finding the value of PE and PB0, we have to use this expression. We have to use, okay, this expression. One day I am going to use this expression. I am going to use, okay, PT, that is equal to PA0 into XA plus PB0 into 1 minus XA. This expression I am going to use, isn't it? Okay, the PA value, the PA0 value I know, PB0 value I know for one particular temperature. If we change the temperature, then definitely this PA0 and PB0 value will change. Okay, therefore the total pressure of the system is 760 mm of mercury. I substituted here, and I substituted the value for the PA0 and the PB0, and you have to find what is the value of XA. Okay, okay. All of you tell me what is the value you are getting here. You tell me what is the value of XA you are getting. Hello. Okay, hello.
Sir, 0.88.
The value of XA, that is equal to 0.88. The meaning is, okay, the 68 is the boiling, 65 is the boiling point of 65 is the boiling point of a pure methanol, 78 is the boiling point of a pure ethanol. I have selected a temperature of a 68, which is between 65 and 78. The meaning is it is a mixture. It is a mixture. Okay, the mixture boils up to 68 degrees. Good. What is the composition? The composition is, the composition of that mixture is methyl alcohol is 88%, and the remaining maybe 12% is the remaining ethyl alcohol. That is the medium. Okay, therefore, and we have to find out that this is the liquid state I have found out. Okay, this is state, that is the XA is nothing but here the liquid composition I found out. Okay, then what about the vapor composition? I have to find out the vapor composition also. Okay, to find the vapor composition, what we have to do? Okay, to find the vapor composition. Okay, the vapor composition I can write like this. Okay, that is the see here. that is partial pressure of A divided by total pressure, that is equal to Y of E. That is equal to Y of E. This partial pressure I can replace with this one. Okay, but partial pressure of A, that is equal to equilibrium vapor pressure 0 XA. Okay, therefore I can write Y of A, which is the mole fraction in the vapor state, that is equal to P of A 0 XA divided by, okay, the total pressure here. Okay, therefore which is nothing but what is the vapor pressure here? This one, 794.32 into 0.88, then whole divided by 760, whole divided by 760. Okay, all of you, and try to tell what is the value that you are getting for this YA. This is called the YA. This is equal to YA. Okay, then you can let me know what is the value that you are getting. This is equal to YA. All of you tell me what is the value that you are getting.
0.919.
Wait. Wait. 0.919. That's all. Okay, it's not having any unit. Okay, therefore the meaning is, okay, similarly you have to find it for different temperatures. You have to find it for one temperature, and we have selected one temperature 68. For that temperature we found out what is the equilibrium vapor pressure PA0 PB0, and we found out what is the value of XA. We found out the value of YA. That's all. Okay, similarly the other temperature also we have to find out. What is the other temperature? 70, 72, 74, 76, like that. For all the temperature you have to find out. That is the that is the problem. Okay, so here again I will explain. Okay, see here three different see here. The first case is pure. My first object is the pure methyl alcohol. Pure methyl alcohol. Okay, methyl alcohol. It is methyl alcohol. Okay. Okay, it is liquid. Here it is liquid, here it is vapor. Isn't it? Okay, these two are in equilibrium. My objective is first I have to find out what is the boiling point of this methyl alcohol. Boiling point of methyl alcohol. How I found out? In the expression given, in the expression, okay, that is the vapor pressure and the temperature relation is given, isn't it? Vapor pressure and temperature relation. Okay, using that one I found out the boiling point of a methyl alcohol as a 65 degrees Celsius, isn't it? Okay, next comes here. Okay, this is the boiling point of pure ethyl alcohol. Ethyl alcohol. This is EEOH, ethyl alcohol. Okay. Therefore, this one is the liquid and this is the vapor state. This is the vapor. This is vapor and this is liquid. These two are in equilibrium. The boiling point of ethyl alcohol I found out 78 degrees Celsius. How I found out the boiling point? In the vapor pressure temperature relation, I have to substitute 760, which is the total pressure of the system. The definition for the boiling point is when the vapor pressure is equal to the atmospheric pressure. Here the atmospheric pressure is 1 atmosphere. That means the external pressure. Atmospheric pressure, I mean the external pressure. External pressure is 1 atmosphere, which is equal to 760 mm of mercury. Therefore, you have to substitute the 760 in that equation and try to find out what is the boiling temperature of the pure ethanol and the pure methanol. Okay. Therefore, I have selected here. Here I have this is the 65 is the boiling point of a pure methanol, and 78 is the boiling point of a pure ethyl alcohol. Okay, in between I have to select randomly. I have to select some temperature. I have selected 68, 68, 70, 72, 74, and 76. I have selected. Okay, for all the selected temperature. Okay, I have to find out the value of x and y. What about this is 65? It is a pure methanol, boiling point of pure methanol. What is this 78? This is the boiling point of a pure ethanol. Okay. What in between temperature? What is the meaning? This is the boiling point of mixture of methanol and ethanol. It is a mixture. Okay. And this also is a mixture. This also is a mixture. This also is a mixture. Okay. But I don't know what is the composition of each and every mixture, the liquid form, I don't know. Okay, that is called X. I have to find out the value of X for all these cases, 68, 70, 72, 74, 76, I have to find out. Okay, to find that one, the value of X, what I have to do, I have to go for the total pressure. Okay, the total pressure. Okay, okay. Before finding that one, I have to find this PA0 and PB0 value. I have to find it PA0 and PB0 for each temperature. I have to find out. Okay, how to find out the PA and PZ value for a particular temperature? In the vapor pressure temperature relation is there. In that relation, you substitute the value of this T and try to find out the PA0 and PB0. After finding this is for one particular temperature I am talking. This is for one particular temperature I am talking. Okay. Then after finding this one, what you have to do? After finding this PA0 and PB0, then you have to find out the total pressure, equate the total pressure. What is the total pressure here? Total pressure is equal to the partial pressure of the vapor A, that is methyl alcohol, plus partial pressure of the vapor B, that is ethyl alcohol. Okay. Therefore, that is equal to this partial pressure. I can write with the help of PA0 as PA0 into XA. This expression is based on Raoult's law. This expression, okay, plus PB PB0 XB, and this XB I am going to replace with the help of XA, because for binary system XA, sorry, XB for binary system, for for binary system XA plus XB equal to 1. Otherwise, I can write XB is equal to 1 minus XA. That's all. Substitute the value of 1 minus x minus a in here in the place of XB. Therefore, the expression will become PT, that is equal to PA0 XA and plus PB0 1 minus XA, 1 minus X. Okay, this PT is something but the total pressure which is given as 760 mm mercury. This PA0 you found out for one particular temperature, and PB0 also you found out for one particular temperature. Substitute everything and find the value of this XA. The XA we found out. Okay, that's all. Okay, therefore we have to find out the value of YA, that is equal to partial pressure of A divided by the total pressure. This partial pressure of A I can write this PA0 XA divided by the total pressure. I know the total pressure is 760. PA0 value for particular temperature I know. XA value I calculated now. Okay, from this I have to calculate the value of the XA. This XA I have to use here to find the value of YA. That's all. Okay. Therefore, here what is the so far what we have calculated at a temperature of 68 degrees. It is a here the first case it is a mixture of, see here. The first case, this one is a mixture of methanol alone. This is a pure methanol alone. This is a pure ethanol. But if you take here, it is a mixture. This one is a mixture of ethanol and methanol. Ethanol and methanol both will be there here. Ethanol and methanol both will be there. Okay. Therefore, the liquid composition here is nothing but the XA I found out, and the vapor composition here is nothing but the YA that also I found out. That's all. And it boils at a temperature. This mixture boils at a temperature of 68 degrees. 68 degrees. Okay. 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 Therefore, for one particular temperature, I found out the value of XA and YA. Similarly, for the second temperature, the same procedure you have to follow. For the second temperature, the same procedure you have to follow. Okay. The second temperature also you have to do the same procedure. You have to do the same procedure for the second temperature. Okay. For the second temperature, in the vapor pressure temperature relation, you have to substitute 70 degrees and find the value of PA0, PB0. And after finding the value of PA0 and PB0, you have to find out, use this expression, total pressure is equal to something, and find the value of XA. After finding the value of XA, you have to use this expression to find the value of YA. That's all. Okay. Therefore, for each and every temperature, we know the value of TXY. Okay. Therefore, if you know the TXY value for all the temperatures, then it is easy for you to draw the temperature XY diagram and the TXY diagram. That's all. XY diagram and the TXY diagram. Okay, that is what I asked. Okay, all of you can be able to follow. Hello,
Yes,
all
sir.
of you.
Yes, sir.
Can be able to follow. Okay, therefore this is the situation here. Okay, therefore what we have to do, see here. Again, I will repeat. See here. Okay, the solutions of methanol and ethanol are substantially ideal. That is highly mixable, these two. And we compute the vapor liquid equilibrium data. Vapor liquid equilibrium data is nothing but the XY data. Okay, and then and for the system at 1 atmosphere, the system the pressure is 1 atmosphere, and we have to plot XY and TXY diagram. We have to plot. We need the X, Y, T. T is the temperature. Okay, all these data. If we know all these data, then we can draw the TXY and the XY diagram. Okay, then this relation given, this relation is called what is the relation given here? This relation, this is the vapor pressure. This is the vapor pressure and the temperature. It relates the vapor pressure and temperature. Okay. Our first objective is we have to find out what is the boiling point of methyl alcohol and ethyl alcohol. First, we have to find out. Okay. So that what we have to do, we know the definition for the boiling point. Boiling point means the temperature at which this vapor pressure is equal to the atmospheric pressure. Okay, here the atmospheric pressure is 1 atmosphere, isn't it? Okay, that 1 atmosphere you have to change into mmHg because the expression involves mmHg only. For here, substitute 760 mm of mercury, here 760, and rearrange and find the temperature. That boiling point we found it as 68 degrees. Sorry, not 68, 65 degrees we found out. Okay. Similarly, in the second expression relates vapor pressure and boiling temperature of ethyl alcohol. It relates. Okay. Therefore, here what you have to do in this place here, you have to substitute 760 and find what is the boiling temperature of pure ethyl alcohol. That we found it as 78 degrees. Then after that, what we have to do? We have to randomly select, or we have to arbitrarily select some temperature between 65 and 78. Okay. Therefore, I have selected 68. I have some different temperatures. I have selected as a 68, 70, 72, 74, 76, like that I have selected. Okay. Then for each and every temperature, I have to find out what is the vapor pressure using the same expression. In the expression, right hand side, the temperature term is there, at that point, you have to use the 68 And the right side you have to find out what is the value of this PA0 you are getting, that you have to find out. Similarly for PB0 also you have to find out. Okay. After finding the value of PE and PB, you have to use this expression, but the total pressure of the vapor is equal to partial pressure of ethanol plus partial pressure of methanol. This vapor pressure, or oh, wait, this, okay, this PA, sorry, this PA, right, okay, here this PA I can replace with the help of this expression. This expression is a Raoult's law. This expression is the Raoult's law. Okay, with this question. Okay, therefore I express similarly. I change this PB as the PB0 into XB. That's all. Okay, then for the binary system, binary system is only two components should be there. In our system, we have only two components. One is ethanol, other one is methanol. Therefore, for the binary system, XA plus XB, that is equal to 1, and the XP you have to express in terms of the XA here. Okay. Then after that, you substitute in the equation here. Then you can evaluate what is the value of the XA, because we know the value of this PA0, we know the value of the PB0, we don't know the value of the XA, but we know the value of PT. Substitute and find the value of XA. Okay, therefore the first part is over. The second part is you have to find out this YA. YA, this is the vapor composition. Mole fraction of mole volatile in the vapor. Okay, that we have to find out. To that, the expression is partial pressure of methanol divided by the total pressure. Partial pressure of the methanol, this one is replaced with the help of this one using the Raoult's law. Okay, then divided by the total pressure. Substitute and find the value of YA. That's all. Okay. Therefore, what is the value that we got at a temperature of 68 degrees? Okay. The value of XA is 0.88. 0.88. And the value of YA is 0.91. Okay, one set we got. Similarly, we have to go for the next temperature. What is the next temperature here? 70. For the same 70, you have to find out PA0, PB0, and the rest of the procedures you follow, and you have to get the second set of equation. Like the token, you have to do the rest of the things, and you have to get all the data. After getting the data, we can draw the XY and the XY diagram. We can draw. Okay, all of you, are you clear? Hello.
Yes, sir.
Okay. If you want to take a screenshot, you can take. I will minimize this one also. You can take a screenshot. From here onwards, you can take. Okay. All of you, maybe tomorrow you have to show what is the data you got. What are the data, the T, X, Y values you have to tell. Tomorrow you have to tell what is the value of T, X, Y you got for all the temperatures. Okay. All of you can take the screenshot of this one and you can proceed further. Okay. Can I take the attendance? All of you give your attendance. Number 1.
Present, sir.
Number 3.
Present, sir.
Number 4.
Present,
5.
sir.
Present, sir.
6.
Present, sir.
7.
Present, sir.
Wait, 8. 8.
Present, sir.
9.
Present, sir.
Sir, present.
10.
Present, sir.
11. Navinal, number 11. Any problem with the Navinal, or he is absent? Okay. 13.
Sir, 13 present, sir.
Sir. Okay, my 18, 19,
Present, sir.
20,
Present, sir.
25,
Present,
26,
sir.
26,
Present, sir.
28.
Present, sir.
Present, sir.
Sir, 26
Sorry,
present.
okay. 28, okay, is also present. 29,
Present, sir.
30,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
42,
Present, sir.
43, 43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
49,
Present, sir.
55,
Present, sir.
57,
Present, sir.
67, 67, 67 absent. Okay. So 71,
Present, sir.
72,
Present, sir.
73,
Present, sir.
74,
Present, sir.
76,
Present, sir.
77,
Present, sir.
78,
Present, sir.
79,
Present, sir.
81,
Present, sir.
82,
Present, sir.
85,
Present, sir.
86,
Present, sir.
88,
Present, sir.
89,
Present, sir.
92,
Present, sir.
90. Okay. Today's absentees is 67 and 11. 67 and 11. 67 and 11. 67 and 11. Okay, all of you can leave.
Thank you, sir.
Thank you, sir.